I should go to jail for that.
Shame on Malcolm. Shame. Jail time.
They're kind of dirty.
Okay. Number 2.
What?
Is 240 over 289, 161 over 289, and 240 over 161. Number 4 is negative 7 times the square root of 95 over 72, and 23 over 72, and negative 7 times the square root of 95 over 23. Number 6, square root of 3 over 2, negative 1/2, negative square root of 3. 8, 120 over 169, negative 119 over 169, negative 120 over 119. 10, 0, 2 pi over 3, and 4 pi over 3. 12, pi over 4 and 5 pi over 4. 14, pi. 16, cosine theta plus cosine theta times cosine 2 theta all over 2. 18, 8 over 3 plus 4 times cosine 2 theta plus cosine 4 theta. 20, cosine 2 theta. 22, negative cosine 2 theta. What questions y'all have on those? 10.
Yeah, this is gonna be. I don't know. I just couldn't find the right. What'd you get? Formula or I couldn't figure it out. How to get to the. I got pi over 3, and 5 pi. I got storm
All right. Cosine 2 theta equals cosine theta. Solve for theta. Between 0 and 2 pi. What should we do?
Find the formula.
Great.
That is cosine theta equals cosine 2 cosine squared theta minus 1. Cosine of theta.
What are you saying?
Cosine of theta equals 2 cosine squared of theta minus 1.
You're turning this into 2 cosine squared theta minus 1. Is that what you're telling me?
Yes.
Okay. That seems reasonable because we're in just one trig function. Right? So, what now?
Then I subtracted cosine.
Subtracted cosine. So 2 cosine squared theta minus cosine theta minus 1 equals 0.
And then I factor and got 2 cosine theta.
Cosine theta and cosine theta and 1, and minus and plus.
That's right. No, it needs to be the other way around. Otherwise, the 2 cosine theta would square. Yeah.
We want a negative 1 in the middle.
Oh, yeah.
The 2's got to be negative.
That's right.
And you forgot to factor for some reason.
Yeah, I don't know. I just didn't put them in the same equation, so I didn't think that. I don't know.
You didn't put them in the same equation? What?
You didn't put zero on one side and everything on the other. Zero. I didn't put.
Oh, yeah. You were trying to find some other identity or something. Yeah. Yeah. No, that makes sense. All right. What else?
218.
Sure.
Do you really remember 18? Yeah, I messed up bad. I messed up bad. Well, technically, I did mess up too, but it was off by one little thing because I forgot to say it. So you still messed it up? I still messed it up, but I figured it out. No. I forgot. I messed it up, but I figured out what I messed up.
All right.
Right.
So we're supposed to rewrite cosine cube theta as an expression with powers no greater than what?
To the fourth. That's
Well, yeah, that's 60.
Yeah.
My bad.
60.
Let's try again.
16 I
Okay. Secant to the fourth theta. All right.
can do. Change it to sine.
You need cosine?
Or yeah, cosine.
1 over cosine to the 4th theta?
Sure. That seems fine.
That's what I did.
We got all kinds of identities with cosine, so 1 over cosine to the fourth theta seems reasonable so far.
And then I split it into 1 over cosine squared theta times cosine squared theta.
Yeah.
Okay.
I know what I did wrong on this. Never mind.
Wait, did I do that? No, I did that right.
Squared theta cosine squared theta.
And then I
Right.
changed it into the equation that we learned.
Okay. Which one?
Really? 1 plus cosine 2 theta over 2.
What are,
1 plus
this is the 1 over that you're saying, not the.
and then
Brett.
1 plus cosine 2 theta over 2. And then the same thing.
Landon, you seem like you need a nap.
I do. And then I multiply those together.
Okay. So, 1/2 squared is 1/4. Plus 2 times.
Where'd you get the 1 Oh, wait, you separated them out.
Mm-hmm.
I get it now. That's where I probably went wrong.
Yeah, you probably accidentally disappeared a 2
Yeah.
somewhere, probably. And then 2 times 1/2 times cosine 2 theta, which is just cosine 2 theta, right? And then, oh no, that's not right. It would still be over 4, right?
Yeah.
Yeah. I had way too much in my head. That was a mistake.
Wait, how did we do that again?
Let's try that again. It's
We
here.
get 2 of those.
Let me do something else that's going to be useful. Yeah, that I was getting 2 of those. That was the doing too much in my head.
Yeah, and then you like disappeared an extra 2 though.
I did.
Should have been cosine 2 theta over 2.
Yeah, so let's just do all of those pieces. Yeah, cosine 2 theta over 4 plus cosine 2 theta. Yeah, I was about to write it correctly. I did. I corrected the mental error. I was going to do it right, but now I've confirmed. Great.
And cosine squared 2 theta.
Oh no, it's another squared.
We're gonna die.
That's too bad.
Get rid of that. Cosine squared theta.
Actually, let's just go like that.
Then we get rid of it because we need to get rid of it.
2 theta plus cos plus 1 plus cosine 2 theta over 2.
Get rid of the.
Did you figure out your mistake?
I guess I just did it wrong in my multiplication.
You probably tried to do too much in your head too. Mm-hmm.
Forgot all these stupid theorems that we learned in algebra 2.
Multiply the denominator by some.
Actually.
1/2.
8, 2 plus 4 cosine 2 theta. Oh, I made a mistake again.
It is 4 theta.
That one's 4 theta. Yeah. Oh, no, that's right. Plus 1 plus cosine 4 theta.
And then we can.
Combine like terms and we're out, right?
It's so
Yeah.
easy and simple.
But you messed it up.
So
I also messed it up more ways than I realized because I did sine instead of cosine because you know, I think it goes with cosine.
Yep.
I,
Yep. So all kinds of mess up.
it's a surprisingly close answer though. It's only like a little bit off, like one of the SIG and multiplication error off. No, it was
Any other questions from this lesson so far?
no. It was kind of easy. I just wanted.
All right.
It was.
Let's do the rest of the examples.
Except for the stupid mistakes.
I'll give you your last homework of this unit, which means that we have a test a week from today.
Oh, a week from today. Oh, thank goodness. Oh, I don't know. I was thinking like.
I would be fine if it was Thursday.
Well,
Except for the fact that we have a
should
unit
finish right
in
now.
between. Hey, we have a unit to do, so it's not going to change anyways.
Let's see.
We have a lesson to do, so.
I'm gonna hurt this man. I'm gonna hurt myself. Wait. No, bro.
All right.
That's.
We haven't learned half angle identities, right? We learned power reducing, and that's where we stopped. Am I correct?
Maybe.
Am I remembering? All right. Half angle identities. Again, all the ones that are in this chapter, excuse me, not this chapter, this lesson you will be given. You don't have to memorize these, but the rest of them you have to memorize.
Yippee.
All right. Half angle identities. Are you ready? The sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Excuse me. The cosine of theta over 2 equals plus or minus the square root of 1 plus cosine 2, no, not 2 theta. Cosine theta over 2. Tangent has 3 variants. You can get to one from the other, but I'm going to just give them all. Tangent of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. What am I saying? Oh no, I'm saying it right. Yeah. I'm saying too many things in my brain to get my brain twisted up. And I was like, what? Look, it's sine over cosine. And then I thought, oh, I just wrote cosine over cosine. And then I realized, oh yeah, I did. And that's what I meant to do. We got this. It's going to be okay.
I don't know if it is.
Also, tangent of theta over 2 equals 1 minus cosine theta over sine theta.
That means that sine theta over 2 is equal to cosine theta over 2. Because
What are you saying?
No, it isn't because of plus or minus.
dang, I was so excited.
The tangent of theta over 2 equals, excuse me, the sine of theta over 1 plus cosine theta.
Yippee.
Well, actually, sometimes they will be the same.
Occasionally.
Rather sparingly, but occasionally.
Y'all are silly. Okay.
What?
I think my short silence jokes where it went down to nothing like it. It's like, oh no.
Let's find the exact value of the sine of 75 degrees. That's not words. Special angle. Oh no. So we got to turn it into something else. We got now all kinds of tools we could use. Actually, this one, if I'm not greatly mistaken, could be done with, uh, 45 and 30. This could be done with some identities.
The product, the ones that we're just learning?
It probably could be done with product, but we're going to do it with a half angle identity.
Or yeah.
That's what you meant to say.
That's did what that.
The product of a half.
I
I
think I'm just excited because this Friday and Saturday is gonna be snowy and really cold, which probably means I'm not gonna work.
Where do you work?
He works at a car wash.
Oh yeah, you definitely got
This is where you live in Lubbock, Texas, so you have to add, I'll believe it when I see it. Okay. How can we do this with half angle identity?
So, hold on. What is the, instructions to this? Find the exact value of it.
Just plug the thing in.
We're finding the exact value. Wait, can we just do like the...
How about we do what 75 is half of what?
150.
Yeah, makes sense. Oh.
This
okay.
makes sense. Okay.
And then we just like.
Okay. Is 150 related? Does it have? All the words are jumbling up in my brain.
Special. Is it special? It's a little bit special.
Is it special? What's the word that I'm trying to, because my brain's saying co-function. What am I trying? Reference angle. Thank you. That's the word my brain is trying to get to and struggling. Is there a reference angle? It's a special angle. 30 degrees. True enough. That's great. 150 is over here, right? So it's going to be negative when it's sine and positive when it's cosine, right?
No. What?
It should be positive when it's sine and negative
Yeah.
when it's
That you know what I meant. Okay. Anyway, now we can use an identity.
Yeah.
Right? So this equals plus or minus the square root of 1 minus
But it's minus 1.
the cosine of 150
It's not though.
degrees over 2.
And now we plug that in and we get 1 minus.
Okay, what is the cosine of 150 degrees?
Negative square root of 30 over 2.
Negative. Oh yeah.
Because it's going to be negative.
Yes.
So it's a negative square root of 3 over 2. Yes. 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 It's a good chinka chinka. Yes. You don't get what I'm saying? No. Ka-chink. It's going to become positive. Yes.
He was just saying it like a total weirdo.
You're a weird total nerd.
Well, it's a little weird to begin with, but it works. People remember it. What do you mind? I wish I came up with it.
Who came up with it?
Some other teacher.
Come on, what?
All right, so we've got plus or minus the square root of 2 plus the square root of 3 over 2 over 2. Okay, now what?
Too bad it's not.
Oh,
Well, too bad it's one, but.
Too bad divided by 2 is 1, but too bad we can't do that.
Should we cancel out? Is just 2 plus the square root of 3?
Couldn't they?
Well, this, to flip it up here, would be, this is 2 over 1. We flip it to 1 over 2.
And so actually it would become to the 4th instead of...
Yeah, not to the 4th.
Over 4.
Yeah, which means, unless we made a mistake, which I don't think we did, the key is wrong, because the key still has it as a 2.
The key is wrong.
I'm pretty sure the key is wrong. I don't see a mistake unless y'all do.
I don't.
It's weird how much the key is wrong.
It is weird how much the key is.
The key
You would think
sucks.
the key would be on a quadruple check.
Yeah, but I wonder if it was quadruple checked by the same person. Did they rush through the key or something?
See, nowadays, You make the key and let AI do it, and then there won't be a mistake.
Well, AI can definitely.
Not stuff like this. They're not going to hallucinate math. Not they'll hallucinate. They'll hallucinate who came up with it. but I mean, you give a decent enough prompt on a math problem, it's not going to hallucinate that. It hallucinates all kinds of stuff, like lots and lots and lots of
It
stuff.
hallucinated on his chart and it started talking about Percy Jackson while he was
Yeah,
trying
it
to
did.
figure out about identities.
I feel like you needed some better prompt engineering going on there.
Perfect until it got down to this half
I
angle.
copied that off the website. I did not make that through
I
AI.
was confused because it was
That was
all
just a little
perfect
subscript at the
until
bottom
the
of the
half
website.
angle.
That's
It said
funny.
Percy Jackson.
All right, y'all do guided practice 5B. Ready, go.
That's one of the few things that is not.
And I want you to do it using half angle identities. There's almost certainly other ways you could do it, but I want you to do it with half angles. Ready, go.
Where's my B? Oh, it's on page 349. It's kind of like right by the stuff. 7 over. Wow. 14 over 6. Wait, what?
Are we gonna have a complex fraction in the first step?
Well, if you do, then make it not a complex fraction. Honestly, these with the radians are probably, as long as you have either the half angles memorized solidly or have it on a chart, honestly, probably doing it with a half angle is probably easier on your brain than doing it with subs, because you don't have to do mental gymnastics to add fractions weirdly.
I've got to be doing something wrong because I just found the answer without doing any. That's gotta be wrong.
That sounds like a classic Reese blunder.
Or he is just way smarter than Honey West, and we are just twisting in the wind.
He probably beats out you and me.
What?
But we've already known that.
I just did that. Yeah. Oh, okay. That's where it is. It's okay. Just delete it.
I just tried to write 14 and I wrote LL.
What?
That was weird.
What?
I tried to write 14 and I wrote LL.
What is this, tangent? Okay, so which one? Oh, no, this isn't tangent. Oh, I wrote sine.
It doesn't come out to the special angle.
Holy cow.
That's what I'm saying. I can't make this anything special. It's just gonna be stupid.
I don't know what to do.
Don't cry at all.
I feel like it.
Oh, man.
Oh.
Use the addition, subtraction, like. I can't remember the name of it now.
What are you saying? No, do the half angle.
I didn't get 7 over 6. I got 7 over 12.
Well, you
That's
did
the angle I started with.
it. I don't know what you did. What did you do?
What did I do?
I don't know what you did.
Andy got the same thing as me too.
Well, so it would be like you would turn this into the tangent of 7 pi over 12 divided by 2. Excuse me, of 6. 7 pi over 6 divided by 2. I can't see what I'm writing. What did I write? Because 7 pi over 6 divided by 2 is 7 pi over 12, right?
That's not the one I used. I used the sine over. Oh, I used sine over. It was
That's fine. Doesn't matter. You can use it, whatever one you want to use.
Okay, no.
Doing this one seemed reasonable in my head. I don't know. I kind of think that if you do it with either one of those other two, you're only going to get half the answer, though. But maybe not. The book only gets one answer. Maybe one of them gets chucked in the bin.
Seems right. I got plus or minus the square root of 2 plus the square root of 3.
The book says that it's -2 minus the square root of 3.
-2 minus the square root of 3.
I get plus or minus the square root of 3.
Plus or minus the square root of
Plus or minus the square root of 3.
how'd you get plus or minus
7
the
pi
square root
over
of 3?
6
Not plus or minus the square root of the square root of 3?
I'm
is
sorry, how did you get the square root of square root?
No, I didn't.
Here.
I got the square root
I did the wrong
of
thing.
2
That's what I
plus
did.
the square root.
I did the sine instead of the cosine.
Classic blunders.
From race.
Sine, cosine, tangent, all the things.
There's too many things.
All students take. It's positive.
Wait, there's no square root in those.
No, that's,
Should I
oh my
just
gosh.
write in the
I keep writing the wrong trig function in my brain and on the paper and everywhere else.
That's what I'm doing.
It's negative, not positive. Negative.
But they it would just be the square. It would just be 2 plus the square root of 2.
Cosine of pi over 6 is square root of 3 over 2.
Yeah.
Over 2 over 1 minus square root of 3 over 2.
And over 1 plus, yeah.
Mhm.
And multiply by the conjugate.
Plus or minus square root of 2 plus the square root of 3 over, well, that's going to go away, right? The over 2's are going to disappear. 2 minus the square root of 3
And then you
multiplied by the conjugate. Yes, I agree. I was thinking that like way up here. I actually thought about just multiplying down the conjugate up here. That might have actually been even easier. I don't know. 2 plus 3, square root of 3 over 2 plus the square root of 3. Excuse me. Minus the square root of 4 plus 4 times the square root of 3 plus 3 over 2 minus 3, right?
2 minus 3 is -1.
It is.
Which means everything's just negative.
Yeah, it's going to flip all the signs. Yes. Plus or minus the square root of 7 plus 4, well, -7 minus 4 times the square root of 3.
Yeah, I was thinking of it all.
Which identity did you use?
I used the sine over that 1.
Sine of 7 pi over 6 over 1 plus cosine of 7 pi over 6 is what you used, right?
Yes.
Great. Sine of 7 pi over 6 is also negative.
Oh, it's
-1/2 over 1 minus the square root of 3 over 2, which equals -1/2 over 2 minus the square root of 3 over 2 Streams over means goes away. -1 over, actually let's just flip it all positive because it's all negative. Multiply by the conjugate. 2 minus square root of 3 over 2 minus square root of 3. And then 2 minus square root of 3 over 4 minus 3. 2 minus square root of 3. Which is quite possibly equal to that. We just have to do a bunch of weird algebra to get there. Possibly. Doing it, did you use that one or did you use the other one?
Square that and get to there.
Square this?
Yeah, and then we would be able to get to that without having to do any weird algebra.
Well, you can't just square something and it be the same.
But it would be the same as the square root of that.
Well, if you squared
If
both
you were
of
to
them,
square
then
both sides, it would remove the square root.
Oh, I see what you're saying. Not the whole this, but
Just
I
square
see what you're saying.
minus the square root of 3.
Probably. We could definitely, certainly try it and see if we ended up with the same thing. Did you use that one or did you use the one with the sign on the bottom?
I used cosine over cosine.
Oh, this one?
Yeah.
What about you? Did you get something else? Did you do this, get this? Where did you get stuck?
So I got to, or what step was it? It's, no, on the left side. It's right in the middle, that big giant step.
Oh, you did this.
Yeah, I got to there and I cracked. Because it's like.
You got to get each of these as you got to combine the fractions.
Yeah.
Multiply this times 2, this times 2.
And then those twos will cancel out on each other.
Yeah, and then they'll cancel out on each other, which is where it goes to this. And then the conjugate. Okay. Next one. Let's do guided practice 6A. Oh, it looks ugly.
It looks very ugly.
Well, we've got to end on an ugly one. This probably won't be the last one. We've got to end on an ugly one so I can leave it up for Algebra 1 to look at.
I thought Algebra 1 was hard when I wrote that Algebra 1.
Honestly, Algebra 1, you found gold. Congratulations.
Rick. Once you actually figure out what algebra is.
Algebra 1 honestly is difficult because you're doing a lot of things for the first time. In a lot of ways, Algebra 1 is harder than Algebra 2. Pre-cal is definitely harder than calculus. Like, no question. Like, definitely. So, anyway.
Maybe the hardest class I've taken, period.
It probably is.
Any subject.
That's entirely plausible. All right. So, 2 sine squared x over 2 plus cosine x equals 1 plus sine x. And we're supposed to solve on the interval 0 to 2 pi. So,
So you don't have to do that in times whatever, or times.
right. So, what could we do?
Put in a formula in there.
What are the...
You mean an identity? Is that what you're trying to say?
Yeah, identity.
Sure, we could probably use an identity or 2 or 10.
Yeah, so on the first one alone, we can do at least 2.
Oh, yeah.
Wait, that's a square.
It does say squared. Oh no.
So do we...
Oh no.
Could we just square the outcome of the half angle identity and it wouldn't be the plus or minus square root? It would just be...
Wouldn't that be, could we convert?
Wait. Time out. Wait.
Do they just like cancel out? That sounds awesome.
Yeah, can we take that 2 sine x and just be like.
What is the identity? What is the half angle identity for sine?
The square root of 1 minus cosine over 2.
2 times.
And if we square that, we get
all
all on
this.
the bottom and we don't have to work.
It just cancels.
It just cancels.
Wow.
That's beautiful. We
We want them all to be squared if they're half angles. We square everything. The 2's cancel, and so is the square root.
Cosine x over 2 plus cosine x equals 1 plus sine x. And that cancels. And that cancels.
And so does the 1.
The 1 doesn't cancel.
No, because but the 1 on the other side.
Well, okay, it does in a minute, but it doesn't yet. 1 equals 1 plus the sine of x minus 1. Sine x equals 0. Where is sine 0?
It's at 0 and at pi and at 2 pi. Or well.
Is it inclusive? Let's see. It is inclusive.
What the heck was that noise?
The book always leaves off the 2 pi. I don't know whether the mistake and whoever did this book, I don't know whether it was in the inclusive part, like putting a square bracket, or whether they just were like one of those ends is a mistake, but it always leaves off that one, always.
Put a 0 in, and the 0 would be left off.
Right. And sometimes you do like from 0 to 2 pi, like that.
Yeah.
That's not unusual, right? Because 0 and 2 pi are kind of the same place, kind of, depending on what context and how we're looking at things. Yeah. All right, y'all do the other guided practice. Ready, go. 6B. Some kind of wonderful.
Don't know what Malcolm's doing right now.
My pen disappeared.
Pay no attention to the man behind the curtain.
I just heard it.
Or fluffy-headed dudes on the ground. Okay. I'm pretty sure that's how that movie went, right?
What is it called?
Guided practice 6B.
Wizard.
Thank you.
Wizard.
No, that's not what I was talking about. Okay, I
What
didn't
question
realize
is
that.
I answered you, Malcolm.
Thank you, Lyndon. You're the best.
No, he's
None
not.
other can beat you.
No, I'm not. This one's like, doesn't do things as you
This one doesn't do things. Oh no. This one didn't just cancel everything immediately. That's depressing.
Everything immediately. Makes me happy. It's easy.
We can factor. Just immediately.
We can.
How do we factor immediately? Expand.
We definitely cannot factor
We
immediately.
cannot factor immediately. Expand.
Your definition of immediately must be kind of weird.
Oh, there's a 1.
Oh, there's a 1.
No, wait, we can factor.
How do we factor that, Malcolm?
Factor out the 8.
I don't want any square roots in this. But I have to. No, because it's tangent. I don't have to actually. No, it's not.
That's the one I would use. You can use whatever you want.
That's the one I was going to use too.
Actually, you know what? I think that's not the one I would use. I think I would use the other way.
0. Shouldn't it be equals 1?
Yeah, it should be. That was a mistake. I think I would use the other one. Because then you have the binomial on the top instead of the bottom. No, you don't. Because then you got to get like terms and all this, like, or you have to get common denominators and all this crap, right? I mean, you can do whatever you want, but that definitely doesn't seem to be the easiest way to me. But what do I know? That one, you can put tangent back in if you feel like it. Excuse me, cotangent.
I don't know if I feel like putting the tangent back.
8 minus 8 cosine x
Usually after I kill something, I don't like to bring it back.
plus 8 cosine x minus 8 cosine squared x all over, actually, yeah, that's fine. Sine x equals 1. Half tempted to go ahead and multiply both sides by sine x, get that out of the denominator, which would be a possible next step. Look, those cancel out.
Those cancel there, and then you just get 8 cosine squared x plus 8 equals sine x.
There actually is quite a bit of canceling. Things die, and I like it.
I love it when things die.
Love it when things die in the morning.
What? I don't like things in the morning.
Did you say, did you say I don't like things in the morning? I don't like things in the morning. And by things, I mean people. Actually, it's...
I'm more of a morning person than I am an afternoon person.
Wait, how did you get the 8 out of the cosine squared x?
I just kind of stopped writing in the middle of something. That's what I meant to say.
Here we should redivide both sides by sine x.
Nah, that's a dumb idea. I know what I would do, but I'm not going to give away the next. Because the next one is easy. If you're doing what I'm telling you to do and memorizing your identities now, instead of waiting till the day of, instead of waiting till the day before the test.
I would never do that.
Because, you know, good luck.
I figured it out, except it equals 0. Is it supposed to equal 0? Or is it supposed to be undefined?
UND?
No.
Oh, you
No,
know it's 0.
no.
It would be 0. It would be 0. There we go. I figured it out.
Wait, 1 minus cosine squared x is just like.
This particular problem, by the way, wouldn't be able to be on this test because when you get to the finish line, you can't do it without a calculator because it's not going to give you a
Perfect answer.
a vocabulary, not vocabulary today, a special angle.
Exactly. Special angle. It doesn't need the special angles.
Excuse me.
Oh wait, I just like matches and stuff.
No,
Can't do that.
The book didn't have a sine x equals 0 answer, though. The book, for some reason, only has the answers I assume that go with this one. I haven't plugged in my calculator to see it yet, whether it matches, but I think the book's missing 0 and pi as answers.
the book likes to do that.
Unless I made a mistake, which is definitely plausible.
No, because I came up with the same thing you did.
Okay, because you can't make mistakes, apparently.
We'd have to make the exact same mistake.
Well, that is also possible. I can't remember how to do this in this thing. Landon, how do I put this in the degree mode?
You go into, wait.
I know I could figure it out, but you probably know off the top of your head.
Shift setup, then you go down and you click degree.
Set up. Yeah, that makes sense.
Then it says angle, and then
Yeah.
click one of the 3.
Yeah.
Really loud.
Inverse Sine, right? Of 1 divided by 8. Enter. I got something different than the book got entirely.
Did you get 0.1253? Oh no, that's.
I got 11.25 degrees.
Did you get, you know what? The inverse sine of 1/8?
Mhm.
I got,
Oh, I bet I need parentheses. Hold on.
Oh, yeah.
I bet I did. Hold
I
on.
got 7.180.
Inverse sine of 1/8. Let's try that again. Yeah.
7.2.
Now it does match the book. So x equals 0 and 7.17. What is it?
7.18.
7.2 and 180. Because we're all in degrees, because I did degrees. And whatever the other, let's see, all students. So 180 minus that, so minus 180 is 172.8.
Yeah, if I was an algebra 1 student and I saw that on the board whenever I walked in, I would be
All
like,
right, how we doing?
we had 12 then.
We're doing pretty good. All right. I have always skipped those. Do I want to do that this year? Yeah, I do want to I want to omit those this year too. Yeah. Because I'm going to tell you right now. You're never going to use those in calculus, ever. I used to talk to this other high school math teacher, and he had the exact same experience that in college, he used a half angle identity once in a calculus class. And I pretty much did the same. There was like one time, I think it may have been a double angle identity. And those are ugly enough that you're not going to use those. It's just not going to happen. So.
What are you doing instead?
You just don't use them. Like you're not going to run into a calculus problem where you have to do that.
Okay.
If you do, then learn them. It's fine.
Calculus better. If I will like it. I probably won't even do
Calculus. So, aren't you thinking you're still going to do like some business nonsense, right?
Yeah, probably.
Then you're going to do calculus, and it's going to be harder because it's going to be business math 1 and business math 2, which is business math 2 is Cal 1 and Cal 2 shoved in one class, and it's all word problems.
Yeah,
I tutored a lot of business math 1 and 2 when I was a math tutor at LCU. Lots. It's pretty. It's like this, like pre-cal, but with word problems. They're both difficult classes. They're not easy. They're not easy at all. I mean, y'all can do it, but they're definitely difficult classes. I think a lot of colleges probably use them as weeder classes, probably, but you also get to take statistics. Yuck. What time is it? Because it's boring.
Yeah, I was about to say, statistics seems very, very simple.
I like simple. I don't like boring. Boring is good.
Boring is good. Boring is
Very good.
Is very good.
From one thing I like to be boring. Math. I like it. I like it to be tedious and boring.
You like it to be tedious?
I'm really tempted to give y'all a test on Thursday instead.
What, you're not gonna give us any homework? That way we
Yeah, I want homework.
I want homework.
I want homework.
We have homework for you.
Yeah, I guess I'll give you homework. That's fine.
Yay. I've never been excited for homework before in my life.
Thank you, Sean. Okay, Sean.
Okay, you're about to make him change his mind. So shut up.
Looks like we're doing
Well, you see, we ended in 22, and we went through example 6, so all you have to do is go and find, oh, example 6, so those ones.
Yeah.
Bruh. It's not rocket science.
It really is. But
Sometimes the things that y'all guess is just kind of like, okay.
It's still fun. It's still fun. It's still fun to guess. Let us have a.
So